Welcome to Two Projects. In this video, we are going to see research on risk prediction of dyslipidemia in steel workers based on recurrent neural network and LSTM neural network. Introduction. The project aims to predict blood lipid risks among steel workers using deep learning techniques. Dyslipidemia, characterized by abnormal cholesterol and triglyceride levels, poses health risks like hypertension and atherosclerosis. By utilizing recurrent neural networks and LSTM networks, a predictive model can identify dyslipidemia cases early, reducing cardiovascular health issues, ensuring well-being and fostering industry growth. Objective of the project. The project aims to create a predictive model for dyslipidemia, a condition characterized by cholesterol accumulation leading to heart-related complications. It uses advanced deep learning techniques including recurrent neural networks (RNN) and long short-term memory (LSTM) networks to analyze and compare algorithms on a dataset of steel workers. The primary focus is on training and evaluating the models, providing insights into the most accurate early disease prediction algorithm. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDLE of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload dyslipidemia dataset. In this module, we will upload the dyslipidemia dataset, which contains relevant data about steel workers, their health parameters and possible risk factors. This dataset serves as the foundation for training and evaluating the predictive models. The second module is pre-processed dataset. Upon uploading the dataset, this module is responsible for data pre-processing. Since deep learning modules require numeric inputs, this step involves transforming and cleaning the dataset. It converts non-numeric data into a suitable numeric format, ensuring compatibility with the chosen algorithms. The third module is run RNN algorithm. Recurrent neural networks (RNN) are utilized in this module. RNNs are designed to handle sequences of data, making them suitable for time series data like health records. The algorithm processes the pre-processed data using multiple layers of interconnected neurons, capturing temporal patterns. Training involves iterative adjustments to optimize accuracy. RNN's capability to capture sequential dependencies makes it valuable for disease risk prediction in this project. The fourth module is Run LSTM algorithm. Long short-term memory LSTM networks, a specialized type of RNN, are implemented here. LSTMs excel in capturing long-range dependencies in sequential data, making them suitable for detecting subtle trends and patterns in health data. Similar to the RNN module, the LSTM algorithm is trained on the pre-processed dataset to predict dyslipidemia risk. The next module is Accuracy Comparison Graph. This module generates a graphical representation of the accuracy and loss of both RNN and LSTM algorithms across multiple training iterations or epochs. The graph enables a visual comparison of the performance of the both algorithms, aiding in determining which one yields superior predictive results. The last module is Predict Disease using test data. Here, the trained models are put to the test using a separate set of test data. The uploaded test data contains health-related information, and the algorithms predict whether dyslipidemia is likely based on the input. The predicted outcomes are displayed, indicating whether the disease is detected or not for each test record. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have dyslipidemia dataset. So these are the column names and these are the records I have. So we will use this data to train the RNN and LSTM models. This is the test data on which we will predict the likeliness of the disease. This is the dataset link text document in which I have a link to download the dataset. These are Python main code files and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Ticketer library to create this graphical user interface. Now click on Upload Dyslipidemia Dataset button. A dialog box opens, select the dataset and click on Open. So it confirms that the dataset is loaded, and we can see top 5 rows of the data and bottom 5 rows of the data, and there are 215 rows in the data and there are 31 columns in the data. Now click on Preprocess Dataset button. So previously we had non-numeric as well as numeric values in the data. So now all the non-numeric values are converted to numeric, and we can see there are 215 records in the data. Now click on Run RNN Algorithm button. So in the text area we can see the accuracy of RNN model. Now click on Run LSTM Algorithm button. So in the console we can see the model building and epochs. So we can see the accuracy of LSTM model in the text area. Now click on Accuracy Comparison Graph button. So in this graph, on x-axis I have iterations or epochs, and on y-axis I have accuracy and loss. And the green color line represents RNN accuracy, red color line is LSTM accuracy, blue color line represents LSTM loss, and orange color line represents RNN loss. And we can see for every increasing epoch, accuracy of both the models is increasing, and for every increasing epoch, the loss is decreasing for both the models. And from the accuracy and from the graph, we can say that the RNN model is doing well when compared to LSTM model. So we will use RNN model to predict disease. Now click on Predict Disease using Test Data button. A dialog box opens, select the test data and click on Open. So in the square brackets I have the test records, and after the square brackets we can see the predictions that if the dyslipidemia is detected or not. So for this record it has predicted dyslipidemia disease detected. And scroll down text area to see the predictions for all the records. And yeah, now click on Close Application button to exit from this window. The conclusion here is the project used recurrent neural networks RNN and long short-term memory LSTM networks to predict dyslipidemia risk in steel workers. The RNN model outperformed LSTM in accuracy, demonstrating its potential for early disease detection. This approach contributes to proactive healthcare interventions, preventing cardiovascular complications and promoting steel workers' well-being.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.